Throughout time, scientists have managed to uncover about 6,000 early human fossils, ranging from skulls to teeth. For some of these fossils, it was a breeze. Researchers could instantly identify them as belonging to, say, the Neanderthals. However, when it came to others, things got a bit trickier. Some fossils just didn't fit into any existing categories. So, what categories of prehistoric humans do we actually know about? Well, up until recently, we recognized 8 different species of early humans. One of these is Homo habilis, which means handyman. You'll recall that Homo is Latin for human. They resembled regular primates, but were pivotal in our evolution. They were the first to create stone tools, which significantly aided their daily activities, such as butchering. Next up, we have Homo rudolfensis. These guys were larger than Homo habilis and boasted bigger brains, but they were still quite distant from modern humans. For example, even though the neurological structure of their brains was becoming more complex, they were probably not capable of using any form of actual spoken language. Then came Homo erectus, the first to walk upright, followed by Homo antecessor, which is considered the last common ancestor of modern humans and Neanderthals, along with a host of other Homo species. Meanwhile, we're still piecing together the story of the enigmatic Denisovans. Our knowledge of Homo naledi is pretty limited too, since it was only discovered in 2013, and it is species number 8. Interestingly, Naledi means star in the Sotho language because they were found in a cave called Rising Star. Scientists were taken aback by them. Everything suggested they were around 2 million years old. But after closer examination and some tests, it turns out that the Naledi species is much younger, between 236 and 335,000 years old. Their hands were adapted to making tools, yet no tools have been found nearby. Long story short, they're a puzzling species, and there's still so much more to learn about them. So even though today we have only one human species on our planet, Homo sapiens, we continue to discover ancient species that are long gone. Now you might wonder why researchers study these extinct species. The truth is, they need this knowledge to piece together the intricate narrative of our prehistoric past. In 2024, a significant discovery emerged, the 9th human species, named Homo juluensis, which translates to large-headed. Researchers suggest that this species hunted wild horses, crafted stone tools, and processed animal hides to survive harsh winters. A researcher from the University of Hawaii noted that the discovery of this potential new species came about while his team was developing a novel method for classifying fossil evidence. Interestingly, one potential representative of Homo juluensis isn't entirely new to science. The Denisovans, first identified in 2010 through DNA analysis of a finger bone found in Siberia, have yet to be classified as a distinct species. Some scientists propose that they may actually belong to this newly identified group. These big-headed individuals could help shed light on the long-standing mysteries surrounding these hominin fossils, which have puzzled researchers due to their mixed characteristics of Homo erectus and Homo sapiens. You see, sometimes it's tough to call a spade when you don't even know what a spade looks like. You get the idea? Many unsolved mysteries linger, simply because scientists haven't had this crucial, big-headed piece of the puzzle. So theoretically, we modern humans could also be considered a bit of Homo juluensis. You don't believe me? Well, watch this. We need to consider 2 key facts for this equation. First, there are the Denisovans, a group we might refer to as Homo juluensis from a scientific perspective. Yeah, this is just a theory proposed by some researchers, but let's roll with it for now and pretend it's a fact. Second, it's important to know that the Denisovans interbred with the ancestors of modern-day Melanesians. These folks inhabit areas ranging from New Guinea to the Fiji Islands and carry between 4 and 6% Denisovan DNA. Now, you might not personally have those genes, unless you've been tested, of course, but the key takeaway here is that there are modern humans today who share genetic links with the Denisovans, or Homo juluensis, or big heads if you prefer. Now, that all sounds pretty plausible, Let's unpack step by step how it happened. Researchers have uncovered this type of ancient human, known as the Denisovans, based on skeletal remains found in Siberia. These ancient humans coexisted and interbred with modern humans, adding yet another layer to our understanding of human evolution. Named after the Siberian caves where their fossils were discovered, the Denisovans are believed to have roamed widely across Eurasia. Evidence indicates that the Denisovans lived alongside Neanderthals and interacted with early Homo sapiens, possibly around 50,000 years ago. A team of scientists successfully sequenced a complete genome from these ancient hominins using nuclear DNA extracted from a finger bone. This discovery reveals that at least 4 distinct human groups existed during the time when anatomically modern humans began migrating out of Africa. Alongside modern humans and Neanderthals, we now have to consider the Denisovans and another small human species from Indonesia, often referred to as the Hobbit, when discussing our evolutionary history. One intriguing question that arises is why Denisovan genes are predominantly found in modern Melanesians, yet absent from other Eurasian populations. Remember that 4 to 6%? One hypothesis suggests that interactions between the Denisovans and early modern humans were limited and brief, especially as humans migrated throughout Southeast Asia into Melanesia. Scientists speculate that only a small number of the Denisovans may have interbred with a larger group of modern humans. This could explain how the Denisovan genes made their way into the gene pool despite the likelihood of infrequent encounters. Anyway, the more scientists dig into our past, the more fascinating things they uncover about our ancestors. Take Neanderthals, for example. Did you know these guys were responsible for creating the very first piece of art ever? I had no idea. But a 2018 study of ancient cave art in Spain revealed what are now considered the oldest known artistic creations. We used to think Neanderthals lacked the cognitive skills needed for art, but it turns out they were actual art pioneers. Not only did they create art, but they also seem to have invented hashtags thousands of years before Chris Messina did it in 2007. Right, I'm kidding, but you'll soon get why I mention hashtags. The artworks found in several caves in Spain include simple hand stencils, a ladder-like drawing, and various other markings. Until recently, these prehistoric pieces were believed to have been made by early humans. But new testing methods suggest they're much older than we thought. Above all, the earliest recognized Neanderthal artwork, which looks like a hashtag, was discovered in Gibraltar back in 2014. To determine the age of these artworks, scientists employed advanced dating techniques using eHarmony and Match.com. Oops, wait a minute, wrong dating techniques. They actually used uranium and thorium radioisotopes instead of the traditional carbon dating. Once the necessary tests were completed, they confirmed the art was approximately 65,000 years old, 15,000 years older than the previously oldest known art from Indonesia. At that time, the only species around were Neanderthals, so it's safe to say they were behind these creations. Modern humans didn't arrive in Spain until about 20,000 years later. Hey, it was a long commute. That rules them out as the hashtag creators. The hand stencil was likely created intentionally, with the artist preparing the pigment and applying it over their hand. Plus, the caves also contain a collection of painted seashells that are an astonishing 115,000 years old. Some of these shells have been drilled, suggesting they might have been used as jewelry. Some specialists argue that the fact Neanderthals created art hints that they might have also had some form of spoken language. So maybe it's time we fully embrace Neanderthals as part of our lineage. They're humans too, just a different branch of our family tree. While these findings are intriguing, some experts remain skeptical about the new dating methods, claiming they're not entirely convinced. Hey, what do you think? Share your thoughts in the comments. There's an amazing place in Ethiopia, East Africa, called Hadar. This place is a treasure trove. We found tons of old animal fossils there. And among those remnants, we discovered something very special. the fossils of a creature called Australopithecus afarensis. One of these guys was found almost complete. You might know it today by the name Lucy, after a famous song by the Beatles. Lucy was a small lady, only about as tall as a kitchen counter. She lived 3.2 million years ago and became a huge celebrity when we found her in 1974. She helped us learn more about our early ancestors, creatures called Australopithecines. Around 10 to 12 million years ago, there was a group of animals that broke into two branches. One of the branches led to modern apes, while the other led to humans. This separation happened because one group decided to stay in trees and became what we now call gorillas, chimpanzees, and orangutans. They moved around using all four limbs and lived in forests. But the other group decided to live on the ground and try walking on two legs. Because of that, their brains started getting bigger over time. And over millions of years, they became bald monkeys who watch videos on YouTube. Yeah, you know who you are. Lucy, like other Australopiths, was a bit different from us. She still looked like an ape and lived during a transitional stage. She could walk on two legs, but didn't do it all the time. Sometimes she climbed trees, just like a monkey. She and her buddies were the first step in human evolution. Then came a new branch of evolution, Homo habilis, or handyman. They were the first members of the Homo genus because they were the ones to start developing stone tools and first show human creativity. They probably used these tools for scavenging and processing food. We found the first clues about them back in the 1960s. They walked around East Africa about 3 million years ago. They were pretty small, about 4 feet 7 inches tall. They didn't climb trees anymore and mostly walked on the ground. Their skull shape already resembled ours, unlike the more pear-shaped heads of Australopiths. That's because they had larger brains. After them, we had Homo erectus, the upright man. They lived about 2 million to 70,000 years ago. The name hints that this was the first hominin species that walked on two legs almost all the time. They were also the first to migrate out of Africa, spreading to Asia and Europe. And here, we had the real breakthrough. Representatives of Homo erectus had even larger brains and learned to make more creative and advanced tools. They created the first choppers, cleavers, and hammers, and used flakes as scrapers and knives. They probably used a lot of things, wood, bark, and even grass to make the first strings and ropes. With all that, they learned how to hunt large animals and probably hunted together a lot. They were also the first ones to start using fire, which changed our history forever. Over time, more Homo species emerged, including the famous Neanderthals. They're known for their European roots. They split from our common ancestor around 400,000 years ago. Now, even though we share one common ancestor, we didn't evolve from Neanderthals. They were a separate branch. All Neanderthals went extinct, but our evolutionary branch coexisted with them a long time ago. Neanderthals were resourceful, hunting both land and sea creatures. They left behind thousands of stone tools and even decorated caves with paintings. They had their own ceremonies, too. They started to bury those who passed away. They probably noticed that leaving them in the wild leads to spreading diseases and attracting scavengers. But they also showed care and love in their burial rituals. Then it was time for archaic Homo sapiens. They lived around 500,000 to 200,000 years ago, emerging in Africa and Europe. This was the last leg between our ancestors and our modern species, Homo sapiens. The brain just kept getting bigger. They started to show more complex behaviors, not only burial and interesting stone tools, but also smart hunting strategies and planning for the future. They probably had a diverse diet that included both hunting and gathering. And finally, we reached the anatomically modern Homo sapiens. They emerged around 200,000 years ago in Africa. They had a similar skeletal structure and brain size to modern humans, and their behavior was pretty close to ours. They had complex social structures, started thinking in symbols, and so on. They migrated out of Africa around 60,000 years ago, spreading across the globe and eventually replacing other hominin species, such as Neanderthals. They started to create their first languages and form their first words. The first words were probably very simple, like ah, to call someone, and ma for babies. After evolving into our final stage, we started advancing in our cultural and technological development. This development became very rapid over the last 200,000 years. About 12,000 years ago, the Neolithic period, also known as the New Stone Age, began. It marked the end of the glacial period. Humans started living in settled villages instead of constantly moving around. This change was brought about by the advent of agriculture, which allowed people to grow crops and raise animals like goats and sheep. Early humans started to domesticate animals, such as sheepdogs, for herding. We also started making the first art, leaving famous drawings in caves, handprints, animals, mostly cows, hunting, and many others. We even created the first currency. We began using clay tokens for transactions. This marked the beginning of commerce and the use of money. And finally, we started writing. And now the events could be recorded and passed down through written records. This is when history officially began. From that point on, we saw the development of agriculture, the rise of complex societies, the invention of writing and the wheel, and the emergence of civilizations. Our tools became more and more sophisticated, languages appeared, leading to the diverse cultures and societies seen today. So, why have we stopped evolving? The truth is, we haven't. Human evolution is an ongoing process, although it's not as dramatic as it used to be. We adapt to different environments, have different skin tones, appearances, body sizes, and genetic mutations that have influenced traits like lactose intolerance or resistance to certain diseases. But the world we live in today is very different from the one our ancestors inhabited. We don't suffer as much because we've developed technology, culture, and social systems. Thanks to this, evolution slowed down, seeing that we're doing okay as we are now. What we started experiencing is cultural evolution rather than a physical one. Plus, 200,000 years is a pretty short time period, considering the time span of the universe or even of our Earth. We should see what happens to us in hundreds of thousands of years. I won't be around then, but there are some theories about that. There's a big idea that, in the future, humans and machines might merge into one super being. We call it technological singularity, a state where we humans lead our technologies to the point where we won't be able to control their development anymore. For example, if AI gets so advanced, it will change everything about how we live. Despite the current rise of AI, we shouldn't be too worried about it taking over the world, at least not in the next few decades. All we've developed now is weak artificial intelligence, little simulations. They might look scary to those who don't know much about AI, but the truth is, they have yet far to go before they reach the grand complexity of the human brain, not to mention consciousness. However, many people believe it's only a matter of time before AI reaches this level of intelligence, and then our world might change forever. There are other possibilities too. For example, one day we might reach a level where we merge with machines and learn to upload our consciousness in the cloud. In that case, we might become a hive mind, taking over the internet using our brains, becoming one giant consciousness. No matter what happens in the future, one thing's certain: technology is changing fast, and it's going to affect all of us, sooner or later.
Imagine that one day, poof, all the big, furry, and feathered creatures just vanish into thin air. Humans disappear as well, and now there's nothing left but microbes. What would happen to Earth? How long would it take for complex creatures to appear again? And what would they be like? Alright, welcome to the microbial world. Microbes are the tiniest building blocks of life, so small you can't even see them without a microscope. In this amazing world, there are three main groups of microbes: bacteria, archaea, and the single-celled organisms. Bacteria are everywhere, from the air you breathe to the food you eat. Some bacteria are good buddies, helping us digest our food, and even making yogurt taste yummy. But some of them can be mischievous and cause infections. Archaea are the tough explorers of our microscopic universe. Archaea are the daredevils of microbes, and they showed us that life can survive in the craziest conditions. For example, they can thrive in super hot springs, even in incredibly scorching temperatures. Some of them are even capable of living in volcanoes. They also feel pretty fine in the freezing cold. Certain bacteria can get busy even in icy places like the Arctic and Antarctica. There, they help break down things like old plants and animals that got frozen in time. They work as nature's cleanup crew, turning leftovers into useful bits. Or imagine the darkest depths of the ocean where sunlight can't reach. And who do we meet down there? Microbes again, who make food from all the weird chemicals in the water. And of course, they also live inside you. You're a walking microbe party. Your gut alone is a cozy home to trillions of bacteria that help you digest food and stay healthy. And finally, the single-celled organisms. They can be plant-like, making their own food through photosynthesis, or animal-like, hunting for their next tiny meal. Some single-celled organisms can even team up to form colonies that work together and build complex structures. All these microbes are the foundation of life. At first, there were nothing but microbes on Earth. They were just hanging out and enjoying the simple life. But time kept ticking, and the more years passed, the more they evolved. They changed a little, sometimes acquiring some special abilities and passing these abilities on to their children. Generations come and go, and those changes keep adding up. Microbes became more and more complex. And after billions of years and trillions of changes, they become something as amazing as the animals, plants, and people we see on Earth today. It was a very long and tedious process, so let's try to repeat it now. Like, what if all living organisms on our modern Earth, except for the first microbes, would disappear? Without the hustle and bustle of life, the world would become eerily quiet. Streets that were once filled with people and animals would now be empty and peaceful. Buildings and cities would stand alone like silent monuments to the vanished world. First, we would have a huge disruption of food chains. Without plants, herbivores, and carnivores, the intricate food chains and webs that sustain life would simply collapse. Our world wouldn't be as wild and vibrant. The tiny microbes are cool, but they can't recreate the same big, bustling party that we all love. Also, remember how we mentioned that microbes often eat the leftovers of animals and other organisms? Just like when you eat cake and turn it into energy, they turn these bits into nutrients that the Earth loves. But now, without the big animals and plants, there wouldn't be as much leftover cake. The microbes would still work hard, but their evolution would be really slowed down. Now, you might think that without plants, we wouldn't have any more oxygen. But this isn't entirely true. In fact, trees produce only about 20 to 30% of the oxygen on Earth. So who really helps us breathe? Plankton from SpongeBob. But seriously, ocean plankton, especially phytoplankton, which is responsible for around 80% of Earth's oxygen production. Phytoplankton are considered microorganisms. They're tiny, single-celled or colonial organisms that float around in the oceans, harnessing sunlight. So, if all land plants and animals disappeared, oceanic plankton would still continue to produce oxygen in the oceans through photosynthesis. They would become even more essential for maintaining a breathable atmosphere. Although now these guys would face some big challenges. You see, big animals like whales and fish usually provide nutrients to the ocean. These nutrients are plant food that phytoplankton need to grow and thrive. Without the big animals, there might be fewer of these special nutrients around. The phytoplankton might not grow as well. And since these guys act as the bottom of the ocean food chain, that could have a domino effect on the whole ocean food web. And also, with fewer plants, there's less oxygen being made, and carbon dioxide starts to stick around more. The balance of gases in the air would change a bit, and when the balance tips, it can affect the weather. The Earth's temperature and the way wind moves would change too. Plus, too much carbon dioxide can make the air feel a bit stuffy. Next, animals like moles, ants, and worms as nature's engineers. They're digging tunnels, burrows, and homes in the ground. When these animals dig and move around, they're actually helping the soil. They mix it up and create pathways for air and water to travel through. It's like they're giving the soil a good shake to keep it healthy. So without the animal engineers, the soil might get a bit packed and tight. Water from rain wouldn't be able to seep in as easily. When they're gone, the nutrients aren't getting spread around as much, and the soil might miss its tasty treats. So the whole ecosystem underground could become less cozy and more cramped. But the most interesting question is, what would happen to all our human artifacts? People disappeared, but their builds remained. Let's look at how this could affect the development of microbes on Earth. Our human-made things need proper care. So, if there were no more people around, all these things would be destroyed very fast. Microbes can grow on surfaces, and over time, they would start to cover buildings, streets, and structures. It might not be visible right away, but given enough time, you'd see a thin layer of microbial growth. Nature is a powerful thing. Buildings that were once shielded by human maintenance would now be exposed to the elements. Wind, rain, sun, and snow would all destroy and break down everything we've ever created. And some places on Earth have really tough weather, super hot summers, freezing winters, or crazy storms. In these areas, buildings and cities might even get sadder faster. Microbes would contribute to this too, as some of them produce acids that can break down materials. Slowly, cracks might appear, and materials like concrete and wood might weaken. Humans overestimate their power when they call themselves kings of nature. If we disappeared, in just a couple of thousand years, there would be almost no traces of human civilization left. It would be like we never even existed. But in any case, this event would offer an exciting opportunity for microbes to evolve in a completely new way. With the spotlight all to themselves, they're free to explore and adapt to their surroundings. Some places might become more challenging, while others might become easier to conquer. Microbes reproduce quickly, sometimes in just a matter of minutes. This rapid evolution could lead to a burst of new microbial species. Could microbes rehabitate the planet? Absolutely. Over time, new species of animals and plants would begin to appear. Like the butterfly effect, any small changes would have led to completely new types of life, and perhaps to new types of humans. In any case, these rapidly evolving microbes could reshape the way ecosystems work. They'd interact with each other in new ways, creating intricate relationships and cycles. The balance of life on Earth might be very different from what we know today. What would it look like? Let's leave that to your imagination.
Dinosaurs are some of the most fascinating creatures to have ever walked Earth. It's a shame that we won't be able to have Jurassic Park, where we can see some of the coolest creatures come to life. But we are actually living with some creatures that are just as old as dinosaurs, such as crocodiles and sharks. They haven't changed much since they appeared millions of years ago. But most dinos didn't make it when the asteroid struck Earth. In a way, the asteroid was a giant reset button for the planet. After hitting Earth, this space traveler wiped out almost every living thing. The sky was covered with ash, which blocked out sun rays. That meant that plants couldn't grow, and this made a lot of herbivores, really hungry. As a result, they had to change their diet and adapt to the new changes. This forced some of those dinosaurs to take on a new path in life, turning into some modern animals we know today. If the asteroid had changed its course just a bit, then dinosaurs would have remained the dominant species. So, what would have happened if dinosaurs had stuck around? Well, first of all, evolution would have played out differently for them. Maybe during those millions of years, humans would not have evolved to be on top of the food chain. Imagine a world where dinosaurs still existed today. If dinosaurs had evolved as humans did, then we'd have to compete with them. There were multiple species of humans, but Homo sapiens, also known as us, prevailed. A humanoid dino, or dinoid, would be something strange. First of all, they would look different, more reptilian than us. Our brain sizes would differ, and they would be physically bigger and stronger. Putting a human and a dinoid side by side would be interesting. First of all, dinoids would have scales as opposed to human skin, and their teeth would be sharper. They would probably not have 5 fingers on each hand, and their nails would be sharp claws. Also, we don't know what they would sound like, but they'd possibly be guttural like crocodiles. Dinosaurs had very good vision compared to mammals, so it's possible we'd see dinoids with large eyes. The population of Earth has reached a staggering 8 billion people, and we've changed our environment to suit our needs. With that said, if dinoids were the dominant creatures, then the environment would be suited for them. Speaking of physical features, scientists predicted what dinoids would look like if they had evolved into intelligent creatures that walked upright and had opposable thumbs. These wiggly thumbs are important for evolution, since they helped humans start using tools for defending themselves and hunting. The creature may not look like the ideal reptile, and its appearance might not be flattering. But if dinosaurs had evolved, then these creatures could be your classmate or colleague at work. Not all dinosaurs were alike, as their fossils have shown. Some were gigantic, while others resembled any modern-day animal. The biggest land-walking dinosaur was the titanosaur, although the measurements are only rough estimates based on fossilized bones. It's estimated that the dino was around 122 feet long and lived between 100 to 95 million years ago. It was so massive that its weight was equivalent to 18 modern-day elephants. There were dinosaurs all over the world in different time eras, climates, and landscapes. However, only a handful were known as giants. But though they excelled in body size, they lacked in brain size. Some of the most well-known dinosaurs, like the Allosaurus and Stegosaurus, had very small brains, like me, which means it would have been nearly impossible for them to properly evolve into intelligent beings. Tell me about it. But in the late Cretaceous period, the T-Rex roamed the land. It had larger brains than its Allosaurus counterparts, which were millions of years behind. Even so, the T-Rex's brain only weighed just under a pound. A human brain is nearly 3 pounds. It might have been cool to see a T-Rex evolve into an intelligent being with opposable thumbs on its tiny stick hands. Contrary to popular belief, the T-Rex was actually quite slow, and a human could have easily outrun it. So, we know that these days, they wouldn't belong in any competitive sports that involve running. We know that dinosaurs could be herbivores and carnivores. But throughout their evolution, one thing remained the same: they had small brains. Other forms of dinosaurs were around too, such as long-legged and horned dinosaurs. Either way, they were on top of the food chain even when little mammals had cameo appearances. We have to consider that when the asteroid struck and wiped out dinosaurs, mammals took over the scene. If dinosaurs and mammals had shared the dominant position in the food chain and had followed a similar path in their evolution, then today's reality would be completely different than what we have now. Dinosaurs would have bigger brains and would compete with humans for the title of the smartest creature. One of the reasons why humans and parrots can talk is because of the strength and shape of our tongues. The evolved dinosaurs would have a different skull, shaped to fit such a tongue if they wanted to talk like humans. One of the reasons why humans made it to where we are now is because we evolved to stand upright to detect predators. This was one challenge we had to overcome in order to survive. But what would dinosaurs need to challenge if they were already the most dominant creatures? Some of the big-brained dinosaurs had long legs, which means they could run fast, detect predators, and grab food that otherwise would be beyond their reach. Their evolutionary path would be very different from that of humans, and maybe even more advanced. Their brains could have evolved into something impressive. They could turn out smarter than us and possess quicker reflexes. Imagine dinosaurs discovering gravity instead of Isaac Newton, or a dinosaur writing plays and poems better than William Shakespeare. Imagine dinosaurs possessing the creative knowledge to produce some of the finest art in history. Music and cinema would revolve around dinosaur culture, and fashion would look otherworldly. We would live in peace with dinoids, but we would certainly compete with them. The World Cup would feature dinosaurs and humans playing for their national teams, but clubs would be exclusively human or dinosaur. Some professions would be dominated solely by one species, and more physically demanding jobs would be taken by dinosaurs, like laborers and security guards. Eventually, dinosaurs would take over the world since they would be physically stronger than humans and would have better advantages than us. Humans, on the other hand, would need to figure out a way to keep up with dinosaurs. Mammals had a different path of evolution, where they never became gigantic super beasts as dinosaurs did. Instead, their brains developed and grew big. But even though humans are the smartest creatures on the planet, we don't have the biggest brain. Animals like orcas, whales, elephants, and other apes have bigger brains here. So why are we smarter than them? The answer is we don't know. The brain is the most complex organ we have, and we know so little about it. We don't even know exactly why it's so complex or why it behaves like that. Today's dinosaur descendants, like crows and parrots, have complex brains, which allows them to communicate, use tools, and even count. Bigger doesn't always mean better in this case. A parrot's brain is smaller than a cat's, but it's far more complex and intelligent than that of any feline out there. Some scientists argue that dinosaurs from the movies aren't 100% accurate, and that they used to have feathers. In terms of evolution, some small feathered dinos might have followed the path of primates. They might have evolved into a tree-dwelling primate that may also have followed the path of becoming another species of human. Now, dinosaurs ruled our planet for over 165 million years, and some walk on our planet even today. Well, at least some of their descendants. Our modern birds evolved from what used to be a scary group of meat-eating dinosaurs we know as theropods. It all started during the Mesozoic era, about 250 million years ago, when a group of creatures called Denisomorphs roamed Earth. They didn't look like those dinos that might have come to your mind, like Brontosaurus or T-Rex, but that's the group dinosaurs evolved from. These creatures walked on all fours and were as big as house cats. They didn't look as friendly, though, considering they were more like weird lizards with long, thin limbs. As you'd expect, this group wasn't exactly at the top of the food chain, but they were really fast and agile, which helped them survive. Over time, they adapted and started walking upright, so their legs were under their bodies instead of out to their sides. And over time, Denisomorphs started growing long tails and bigger leg muscles. Their necks became stronger to support the new position they were in, and they even got extra hip bones that helped them move faster and more efficiently. That's when dinosaurs came on the scene, somewhere between 240 and 230 million years ago. Their name comes from the word dinosauria, which means terrible lizard. The oldest dinosaur fossils belong to these fellas that lived in Argentina. This one is even older, but we're still not sure if it's a real dinosaur or its relative, Denisomorph. Now, considering the size of their ancestors, dinosaurs weren't large at the beginning, more like dogs or horses. There weren't many species back then, so if you could go back to that time, you'd see a bunch of reptiles walking around on two legs. But as time went by, they adjusted to different environments, and we got more interesting groups. For example, small and fast predators, like this guy. They all fall into the category of archosaurs, a group that also includes pterosaurs. Yup, their name may not imply it, but these are not dinosaurs. As some dinosaur-morphs evolved into dinosaurs, they got certain advantages, like arms. They could do much more thanks to that. Some could catch prey using their hands. Others could grasp branches. Now, the freedom they got by moving their arms later helped some of them evolve into birds and start flying. Dinosaurs were probably warm-blooded. It means they could stay active all the time. They didn't depend on the conditions around them like, for example, reptiles do. The latter are cold-blooded, and they have to rely on their surroundings to regulate their body temperature. Dinosaurs didn't rule the animal kingdom for the first tens of millions of years of their existence either. Crocs were at the top of the food chain back then. Then the Jurassic period hit, and new kinds of dinosaurs showed up, like those giant plant-eating dinosaurs, for example, sauropods. You know them, dinos with long tails and necks that could eat plants at different heights, such as Brachiosaurus. Allosaurus is another famous dino from that time you will probably recognize. Spikes on the tail, bony plates on the back, good old Stegosaurus. The Jurassic period was that time when dinosaurs started to get bigger and bigger. Then the Cretaceous period came along, and finally, these magnificent beasts reached the peak of their fame. That was the time when the mighty T-Rex took the throne and got to the top of the food chain. T-Rex probably lived around 28 years, but it reached adult size really fast. Now, it wasn't easy to survive back then. T-Rex falls into the category of tyrannosaurs, and scientists have found out those fellas were fierce even when they were at a pretty young age. They discovered a fossil of a teenage tyrannosaur that was 75 million years old, and it had 2 baby dinosaurs inside its stomach. They realized that when tyrannosaurs were at a young age, they went for small dinosaurs, such as these guys, their dino cousins. As they grew older, they started taking on bigger challenges, like those peaceful giant dinosaurs that like to hang out with their group and eat plants. But large predators weren't the only ones that would have made you shiver with fear. That was also the time when fast and smart creatures called velociraptors show up. They weren't some scaly dinosaurs that would catch their prey using those claws in the shape of sickles, like shown in the movies. Their bodies were covered in feathers, and they would grow up to 100 pounds, which is about the size of a wolf. And to bust one more myth, they didn't hunt in packs. Velociraptors probably prefer to hunt solo and use their claws not to slash their prey, but to clutch it. T-Rex and Velociraptor fall into the group called theropods. We mentioned them at the beginning, the creatures today's birds evolved from. But even though velociraptors were covered with feathers, they still couldn't fly. Their wishbones weren't shaped in a way to support flying, and their arms were too short. Maybe it was better that way because during the Cretaceous period, flying dinosaurs called pterodons were the ones that took over the skies. Things had been going really great for dinosaurs until one unfortunate day 66 million years ago when an asteroid hit our planet. It's not that the asteroid itself erased all the dinosaurs right away, but it caused changes in the environment, which made it way harder to survive. At that time, about 75% of animals living on our planet went extinct. The asteroid was really big. When it hit Earth, it created a giant crater in the Yucatan Peninsula and sent a lot of debris into the atmosphere, which blocked the sun right away. For months, dense clouds of dust blocked sunlight. Our home planet was darker and colder than before, which wasn't good for plants. Creatures that ate plants couldn't survive those changes either. So it all turned into a chain reaction when most of the ecosystem collapsed. When the dust finally cleared, all those greenhouse gases that had formed after the impact made temperatures go way higher than they had been in a really short period of time. All land animals that weighed more than 55 pounds were gone. But not everything disappeared. There were fewer plants, but they were less affected than animals, all because their pollen and seeds can survive really messed up conditions for a longer time. So, what we have today is basically the seeds we were left with back then. After the asteroid hit, flowering plants dominated our planet. All non-bird dinosaurs went extinct too. Some species survived as birds. At first, those brave survivors were small, but later, birds evolved to bigger sizes. Now, there's a study that says that if the asteroid had slammed into some other spot on Earth, the fate of many creatures and plants would have been very different. If the rock had fallen maybe a couple of minutes later, it would have hit deeper waters. Less rock would have vaporized and risen to block out the warmth and light coming from the sun. In that scenario, we'd probably still have dinosaurs around. For example, Triceratops was one of the last dinos that had nothing in common with birds. If the asteroid had missed our planet, we would see some of them still roaming around, but since evolution never rests, maybe in a little bit different form.
You run through the night forest for more than an hour. You're even faster than a cheetah. You're not tired or cold. You hear a mouse rustling in the roots of a tree and catch all the smells of the forest. With night vision, you see a bird in the night sky. You can go for months without food or water. Gills allow you to swim underwater freely. This is how evolution made humans in a parallel world, Here, they're ideal organisms prepared for anything they might meet in the wild. In our world, things are more complicated. We evolved, but didn't always get stronger. Humans only survived because they adapted and changed the world around them. A human only has 32 teeth. When they fall out, they no longer grow. But evolution doesn't stop. Our food has become softer and more nutritious. You don't need to chew it for a long time. New diet reduced the jaw and enlarged the brain. As a result, there's no room left for the 4 teeth that are closest to the joint. We call them wisdom teeth. In the future, we'll only have 28 teeth. And even today, 35% of people don't have the wisdom teeth. Homo sapiens is the only mammal to have a chin. This is the protrusion along the lower edge of the jawbone. Even our relatives, gorillas and chimpanzees, have their jaws slanted inward. Anthropologists think that the chin is a result of reduction of human face. Perhaps in the past, the chin supported our powerful jaw and enhanced our strength. Over millions of years, the face has shrunk, but the chin has remained. Put your hand on a flat surface, connect your ring finger and thumb, bend your wrist, and you'll see the palmaris longus. 15% of people don't have this muscle already. It doesn't affect the grip strength and has lost its meaning today. Millions of years ago, it allowed our ancestors to deftly climb trees. Evolution deprived us of this useful skill, but the remainder of it remained with us. Dogs, horses, monkeys, and many other animals can move their ears. This allows them to hear better and communicate with each other. Humans have a long, flexible neck, and evolution has left them without this ability. Still, 20% of modern humans can do it. This is another reminder of a time when we weren't much different from other animals. 10% of people have a Darwin's tubercle in their ear. In the past, we had pointy ears looking like the modern macaw's ones, and this little bump is the proof. When an emperor penguin hatches eggs, it doesn't eat for 115 days. Scorpions can stay hungry for a whole year. Evolution hasn't given humans a camel-like hump of fat or the ability to hibernate like a bear. Every morning our ancestors woke up and fought for their survival. We need a lot of energy for this, so we have to eat every day. This isn't very convenient, especially when your food isn't sold in a supermarket but runs away from you through the forest or field. In the human brain, at any given moment, 100 billion neurons work. Thanks to this, you have a good memory and can talk. This is essential for survival. A big brain has a flaw. For neurons to work, it needs a lot of fuel. It makes up just 2.5% of body weight, but consumes 20% of its energy. In 2 hours of playing chess, a grandmaster burns 560 calories. A professional tennis player will spend the same amount of energy in a single hour. Big brains make us weak. Even a small chimp is much stronger than a human. Why do you need muscles if you no longer swing from branches? But you need a big brain to negotiate and cooperate with other people. Got weaker, and we like lying on the couch more and more. This is a comfortable position for thinking. At night, our ancestors were especially vulnerable. When you sleep in a new place, the left side of your brain is more awake than the right one. This brain reaction is called the first night effect. This is an ancient reaction of the body to the dangers that awaited a human in the dark. 40 to 60 million years ago, evolution gave us yet another fear. We're born with the fear of being bitten by a snake or spider. Apparently, these animals were the main danger to the first primates. Anthropologists say we became runners 2 million years ago. Broad shoulders make it convenient to swing your arms and keep balance. A special ligament extends from the spine to the back of the head. It stabilizes the head while running. No primate has strong gluteal muscles. They only turn on to full power when you're running. Hairless and 3 million sweat glands keep our bodies from overheating. People are perfect runners, but evolution has made us slow. You'll never overtake a chimp on a short distance, and that's not mentioning cheetahs. They accelerate to an incredible 70 miles per hour. But almost all land animals are sprinters and don't run for more than 10 to 15 minutes. Humans are adapted for long distances. Walking 2 legs helped our ancestors solve many problems. They freed their hands to carry food or tools. 2 legs and a straight back made our ancestors larger and even scarier for other animals. When you stand on two legs, you'll quickly see a saber-toothed tiger, which is waiting for you in the tall grass of the plains or the African savanna. Your body weight is distributed over only two limbs, and this has consequences. You can calmly walk down the street, stumble, and get injured over that. Consider this our payment for upright walking. So why do we need toes? Certainly not to hit them on the furniture. When our ancestors lived in the trees, toes helped them cling to branches. Imagine you can work at the computer, draw pictures, or cook scrambled eggs, all with your feet. Cool, but good old evolution has deprived us of this skill. Today, we're not sitting in the trees, but our feet remain flexible. Come to think of it, hooves would be more suitable for us. They're durable and don't need shoes. But until we evolve again, our feet remain fragile. Either of them has 26 bones. This doesn't make our walking or running any safer. You go to the cinema, take your popcorn basket, and start munching on it in anticipation of a great couple of hours. But then you start choking. Those few minutes of coughing and involuntary tears seem to last forever. The human is the only mammal that can choke on its food. We can't eat and breathe at the same time. The reason for this is the structure of our vocal apparatus. Your larynx is down below, thanks to which you can talk, but not while eating. Goosebumps, horripilation, gooseflesh, these are the names of the reflex that makes your skin not smooth but bumpy. This happens when you're cold or scared. Greetings from the Stone Age. Our ancestors were covered in thick hair. When they got scared, the hair follicles rose. This made them large and menacing for other animals. This natural reaction warmed the body as the air grew colder. The body of modern people no longer has long and thick hair. But if that movie is really scary, or you forgot your jacket in the evening, goosebumps still appear. Bears, hedgehogs, bats, some turtles, fish, and insects. All these creatures have one thing in common: they hibernate. Scientists claim that our ancestors were also on this list. In a cave in the north of Spain, researchers found fossilized bones of ancient people. The analysis showed that 500,000 years ago, humans could spend several months hibernating, similar to bears. Thanks to this, they survived Ice Age. Wow, how I miss this skill. Our eyes allow us to see dust in the air and huge mountains on the horizon. We see the world in color and recognize each other's faces. And when it gets darker, our vision quickly adapts to new conditions. But we don't see well in the dark. Evolution hasn't given us the sight of a tarsier. This primate is the size of a baseball and can see perfectly in the dark. Tarsiers could easily catch a beetle flying through the night forest. Still, I wouldn't want my eyes to take up most of my face, and beetles are actually not among my favorite after-dark snacks. How about you?
Remember the Neanderthals? Our superstar humanoid cousins of the Pleistocene era in all their wide-nosed and slope-foreheaded glory? They roamed through Europe and Asia for over 350,000 years before they vanished. This was around the same time our ancestors, the Homo sapiens, decided to take a vacation from Africa and explore the world. We may never know what truly happened to the Neanderthals and why they didn't make it to the present times, but thanks to some hefty archaeological digging and impressive fossil finds, we now know a bit more about them. One theory for their disappearance is that the climate wasn't suitable for them anymore. Supporters of this idea think Mother Nature turned on the Neanderthals and sent them packing. Unfortunately, if we look at Neanderthal archaeological sites in Italy, for example, there are no signs of weather catastrophes that could have wiped out this entire species. Others believe there was a bit of resource competition between Neanderthals and humans. That's why specialists also dug around several other archaeological sites where Neanderthals and sapiens might have rubbed elbows for about 3,000 years. In this case, it does seem that the Neanderthals were a bit behind with their tools. Their technology was like flip phones in the age of VR. But who knows if these two species ever crossed paths in that particular region? The evidence is still fuzzy. How they went extinct isn't the only information we're curious about when it comes to Neanderthals. Other scientists, for instance, are trying to decode some of the Neanderthal molecular barcodes to identify their specific traits, some of which you might share, believe it or not. Sure, Neanderthals as a whole species did, in fact, go extinct. But that's not to say remnants of their DNA can't be found in humans. Now you know how things go when folks live near each other. Some genetic mixing was bound to happen. The evidence? A dash of Neanderthal DNA which was found in modern folks. Now, this is where the plot thickens. Scientists thought that since Neanderthals never lived in Africa, their DNA wouldn't be found in modern African populations. Well, it turns out that African people have about 0.5% Neanderthal DNA too. This doesn't mean our Neanderthal relatives simply teleported through African territories without leaving any trace behind. What this discovery actually implies is that early humans might have visited Europe, mixed their genetic material with that of Neanderthals, after which they returned to Africa. That's a lot of migration. How did we stumble upon that Neanderthal DNA these days, you might wonder? Well, scientists gathered thousands of people from all around the world. Participants came from places like East Asia, Europe, South Asia, America, and Africa. Percentages may vary, sure, but around 20% of the good old Neanderthal DNA is still found in US modern folks. Sure, the average Joe only carries about 2% of that caveman swagger. If you're from certain places or families that have a smidge more Neanderthal in their gene soup, you're looking at 3% tops. Is there anything in particular that we share with our long-gone humanoid cousins? As it turns out, our Neanderthal ancestors gifted us more than just their company for some thousands of years. They also passed down the incredible legacy of their noses. Well, you see, the Neanderthals were outfitted with some seriously high-rising sniffers. These weren't just cosmetic, they were also quite the asset in chilly climates. The icicle-dripping, teeth-chattering kind of cold where your breath could freeze before it leaves your lips. During those days, the Neanderthal noses worked as personal heaters, warming and humidifying the cold, dry air they inhaled. For that kind of extreme weather, these impressive nasal skyscrapers turned out to be quite handy. When our Homo sapiens ancestors decided to leave the sunny savannas of Africa for a spot of frostbite up in Eurasia, they bumped into the Neanderthals. This encounter resulted in not just an exchange of pleasantries, but also an exchange of genes that coded for larger noses. This newfound genetic nugget was discovered by scientists who dug deep into the DNA of over 6,000 volunteers. To complete the study, these scientists meticulously compared this genetic data to snapshots of the volunteers' faces. They measured the distances between various points on each face, such as the height of the volunteers' nose bridges. They then played a game of spot the genetic marker to identify if certain facial traits were linked with specific genes. By the end of this exciting chase, they hit the jackpot. 33 shiny new genome areas were linked to facial features. One standout gene, named ATF3, was traced back to our Neanderthal ancestors and seemed to be the maestro of controlling nose height. Participants with Native American ancestry had Neanderthal hand-me-downs in this gene, contributing to their taller noses. Think of the ATF3 gene as a Neanderthal housewarming gift to us humans, as we stepped into colder climates from Africa. Interestingly, this isn't the first time our ancestors have played pass the gene. Back in 2021, the same research team uncovered a gene influencing lip shape called TBX15. This gene was a little love note from the Denisovans, another set of our ancient relatives, who lived in Asia and went extinct around 30,000 years ago. Another part of the scientific community believes our Neanderthal buddies had this weird genetic feature when it came to their brains. Is that why they didn't make it? Through this theory, it was suggested that US humans might owe our brainy edge to a quirky gene mutation. This mutation gave our neocortex, that's the smarty pants part of the brain, a little population boom in the neuron department. This amazing gene of ours isn't all that different from the Neanderthal version. It's just one amino acid off, just like ordering a coffee with one sugar instead of none. This tiny tweak is found in virtually all modern humans. Meanwhile, our extinct relatives, the Neanderthals, Denisovans, and other primate pals, all missed the mutation memo, at least according to the study. Now, let's not get ahead of ourselves. Just because we have more neurons doesn't necessarily mean we're geniuses by comparison. But these results do suggest that we might have rewired the brain in a way that gave us a cognitive leg up. Also, it's not all about this lone amino acid difference. It's just a piece of the puzzle. Scientists have previously found a whopping 96 differences between our DNA and that of Neanderthals that could have potentially affected our different outcomes as species. Studying Neanderthal DNA also gave us some insight into their relationships. In fact, We now have some solid evidence of what a Neanderthal family looked like, and surprisingly, it's not really that different from ours. For this study, researchers gathered information from a Neanderthal archaeological site located in Asia. They discovered that one particular family included a doting Neanderthal dad, his teen daughter, and a sprightly young lad who was possibly their nephew or cousin. Part of the group was also an older female relative, maybe an aunt or granny. Now, our young damsel would eventually pack her bags, wave a teary goodbye, and leave her papa's home when she found Mr. Right. Had she been a boy like her young cousin, she would have been a happy homebody. But worry not, she wasn't stepping into a world of strangers. Her new community likely had some familiar, friendly faces. But how were scientists able to predict the ending of this story? By browsing through their gene pool, researchers were able to figure out that the Neanderthal social structure was patrilical. What this means is that most female Neanderthals left their homes when choosing a partner and started a new life with another family. The same research shows that our cave-dwelling clans likely weren't living in isolation either. Families living close by were probably visiting the same rock sampling areas to make their stone tools, the equivalent of a neighborhood hardware store. And when they weren't tooling around, they were busy hunting delicious meals like ibex, horses, bison, and other wandering critters. Scientists, however, were careful to add that this ancient family portrait might not represent the full spectrum of Neanderthal social life. They've kindly asked future archaeologists to get more Neanderthal DNAs on the Ancestry websites.
Have you ever wondered what animals looked like when they first appeared in the ancient oceans over 500 million years ago? Well, scientists have been scratching their heads about this for more than a century. And now, they believe that they finally found the answer. So let's take a look at their discovery. You see, our ancient ancestors probably lived 600 or 700 million years ago. They were soft-bodied, so unfortunately they didn't leave any fossils behind. Scientists decided to uncover the secrets of these ancient creatures by comparing them to all the animals that exist today. First, we need to ask ourselves, what is an animal? Well, we know that they're incredible creatures with heads, innards, muscles, and brains. And we know that humans are part of this animal gang too. We're called bilaterians, and we have all these cool features that evolved around 500 million years ago during the Cambrian explosion. But there are also awesome creatures with very simple body plans. We've got jellyfish, sea anemones, sponges, ctenophores, and many more. They may not have fancy brains or muscles like us bilaterians, but they still have the essential qualities of animal life. For example, they develop from fertilized eggs into living beings. So, researchers decided to take a look at them to figure out which group was the earliest branch on the tree of life. To solve this mystery, they used a technique called DNA sequencing. They looked at the genes of these animals. The similarities and differences in the genes help scientists understand how creatures are related and how they evolved. By comparing DNA, scientists could piece together their evolutionary family tree. The list narrowed down to two candidates: sponges, which are basically lazy filter feeders, and comb jellies, which are fierce predators cruising through the oceans. But the controversy remained: who came first? Sponges may seem to be simple fellows. After their free-swimming phase, they settle down and filter tiny food particles from the water. No nerves or muscles for them, but their hard parts make excellent scrubbers. For a long time, scientists believed that sponges were the very first branch of the animal family tree. They thought that before anything else, there had been these tiny single-celled creatures called protozoans. Then these protozoans came together and formed colonies that eventually evolved into sponges. And from there, sponges became the ancestors of all animals, including humans. But hold on. Meet the comb jellies, those mesmerizing creatures you often see in aquariums. They may resemble jellyfish, but they're not even close relatives. Instead of squishing through the water, ctenophores use rows of beating cilia, like combs, to propel themselves. You can spot a sea gooseberry, a common ctenophore, along the California coast. It's about an inch in diameter and quite fascinating to observe. Anyway, now we have two contenders. To find out whether sponges or comb jellies were the first, the biologists turned to an unexpected superhero – chromosomes. You see, each species has its own unique chromosome number and gene distribution along those chromosomes. For example, humans have 23 pairs of chromosomes. So scientists didn't just look at the genes each animal had, they also checked where those genes were located on their chromosomes. You see, as animals evolve, their chromosomes rearrange, and genes move around. Once they move, it's really hard for them to go back to their original spots. So, the clever biologists figured that the animal with the least shuffling of genes on their chromosomes must have appeared first. They basically had to find a puzzle with the least shuffled pieces. To crack this mystery, the scientists compared the gene placements in sponges and comb jellies to their closest single-cell non-animal relatives. These single-cell relatives were like cousins to the first animal and held clues about the original genome. The closer an organism's genome was to the original, the less it had changed and the more likely it was to be the sister. So the research team discovered something incredible. Despite more than 500 million years of independent evolution, sponges, jellyfish, and many other invertebrates share similar sets of genes on their chromosomes. It basically meant that animal chromosomes evolved slowly. It also gave the researchers a golden opportunity to digitally reconstruct the chromosomes of the ancient common ancestor. There was another big problem, though. We had no idea what the chromosomes in comb jellies looked like until the year 2021. That's when brilliant biologists finally cracked the code. They discovered the chromosome structure of a particular comb jelly with a pretty complicated name. Yeah, I'm not even going to try. Anyway, let me tell you, it was like nothing they had seen before. Strangely, the chromosomes of these comb jellies were totally different from the chromosomes of other animals. The scientists were perplexed. Is it because they had changed a lot over millions and millions of years? Or is that because they actually appeared before all other animals? It took scientists some time and a lot of hard work to fill in those missing pieces. And guess what? Finally, they found the answer. It turns out the first branch of the animal tree belonged to comb jellies. Sponges came next, and then all the other animals, including us humans. So let's discuss this little funny creature from which we all originated. Jellies, including comb jellies, are simple creatures with few specialized organs. They can sense chemicals in the water to find their food, and they even have a special structure called a statocyst that helps them orient themselves in the water. Comb jellies are also known as ctenophores. They're cute little creatures that live all around the ocean, from the North and South Poles to the sunny equator. They can be found from the surface all the way down to the deepest part of the sea. These amazing animals belong to the group of invertebrates, which means they don't have a backbone like we do. They come in various sizes depending on the species. And by the way, despite their extraterrestrial appearance, their soft bodies are perfectly designed for their underwater world. They're more than 95% water, which makes them lightweight and agile. Comb jelly is a fascinating creature with an oval shape and 8 rows of tiny comb-like plates. It uses these combs to swim gracefully through the water. And guess what? When it moves, its combs create a magical rainbow effect as they diffract the light. It's like swimming through a shimmering prism. But they aren't as cute or harmless as they seem. In reality, comb jellies are voracious predators. They love to feast on other jellies, and some of them can even stretch their stomachs to hold prey that's almost half their own size. So, their diet consists of other comb jellies, as well as some salps and siphonophores. Talk about having a big appetite. And here's another interesting fact. Even though comb jellies got a head start in branching off from the tree, both they and sponges have been evolving since then. They've been on their own journeys, adapting to their environments and developing new features over time. It's a reminder that evolution is an ongoing process. It also shows how important it is to take care of these unique creatures and their environment. Changes in jelly populations can be a sign of bigger issues, so it's crucial to protect their habitats. But why is all this so important? Well, these discoveries help us understand how animals have developed. By studying the early branches of the animal tree of life, we can understand about the characteristics and traits that all animals share. For example, how they sense their surroundings, eat, and move. We can also learn all sorts of cool things about how animals first emerged and evolved into the wondrous array of species we have today. The scientists were really excited about their discovery. They knew that they had found a relic from a very ancient time. So, there you have it. This discovery is like a magical time machine that allows us to peer deep into the past. It's a treasure trove of knowledge about the origins of animal life. I'm sure scientists will find out more interesting things in the future, so stay tuned. You know what? Every species on the planet needs to adapt to the world around it to survive. Human beings are no exception. We didn't exist millions of years ago. The oldest skeleton of a modern person ever found is about 196,000 years old. But even in this relatively short period of time, our species has evolved a lot. In fact, we've never stopped evolving. At least that's what some scientists think. And some of our traits seem to prove it. About 20,000 years ago, I wasn't around then, only children could drink milk without getting an upset stomach. But then humans domesticated animals like cows and goats. A new gene developed in people's bodies down the generations. Today, about a third of all the world's population can drink milk in adulthood. In fact, this ability actually developed independently among different groups of people all over the planet. Our jaws are also not as big as the ones our extinct relatives had. They got smaller because our soft processed food is nothing like the diet of our ancestors. Our teeth themselves have become smaller too, and some have even disappeared completely. Plenty of people may never develop third molars, known as wisdom teeth. But for our ancestors, these teeth were vital. Third molars usually develop when someone is 18 to 25 years old. By this time, most of our ancestors' teeth had become worn out, so the third molars were possibly replacements. But some slight changes in human anatomy may have nothing to do with evolution. For example, people have generally gotten taller over the past few hundred years. The most likely cause of this is simply better nutrition, as well as access to modern medical care, and perhaps basketball. But what changes await humanity in the future? Of course, nobody can tell for sure, but the experts do have some interesting theories. One possibility is that we could get shorter as we adapt to life on our overpopulated planet. Studies have shown that shorter people consume a lot less energy and resources than taller people. In the era of hunter-gatherers, humans didn't meet many others in their day-to-day lives. Now, people have to adapt to life in densely populated cities. And who knows, maybe given enough time, our genes will respond to this change and reduce the average person's height. Another possibility is that more and more people will look alike. Modern humans travel a lot. As different types of people interact and have children, our genes are becoming more and more mixed up. In the future, this might make some physical characteristics a lot more unusual. The average-looking person might have darker skin and hair, and traits like freckles or blue eyes could become a rarity. Some scientists think that evolution won't play an important role in our future at all. Unlike our ancestors who lived millions of years ago, we now have a very advanced culture based on cooperation and modern technology. So, we no longer need to literally struggle to survive. Because of this, we may actually stop developing as a species and remain pretty much the same far into the future. If our evolution does continue, though, there's a chance we'll become more complex and intelligent creatures. Because of technological progress, the way we deal with problems could depend more on our intelligence than our physical abilities. So our brains might become larger. This may already be happening. I know mine is getting bigger. Some scientists' measurements show that the skulls of Americans are actually getting bigger on average. The room in there for the brain has increased about the size of a tennis ball. Or maybe the opposite will happen, and our brains will shrink. This direction of development has actually been around for a lot longer. Some people think that the male human brain has been getting smaller for the past 20,000 years. Hey, just ask females. If it continues to decrease at the same rate for the next 20,000, it'll end up being the same size as the brain of an archaic human who lived about 2 million years ago. Wait, does that mean we're becoming less intelligent? Well, a bigger brain doesn't always mean greater intellect. We just might be evolving to have smaller but super efficient brains. Another theory is that our bodies might learn to use calories from fast food. Things like pizza, fries, and donuts contain trans fats. These chemicals are difficult for our bodies to digest. But what if humans of the future somehow adapt to this kind of food, if we eat it for long enough? After all, the same process has already happened with milk. In a few thousand years, people may develop genes that can break down trans fats and absorb something healthy from them. If they still enjoy eating burgers and fries, of course. Donuts. People of the future might have less hair than we do today. Hair was vital for our ancestors. It helped regulate their body temperature, keeping them warm in cold climates and cool in hot environments. Even today, we still have practically the same amount of hair as many apes do. But some scientists have pointed out that our hair is nowhere as near as important to our survival as it once was. Since we now have modern heating systems and clothing for any environment, maybe given enough time, we'll become a lot less hairy. Then they'll be saying, he wasn't very fuzzy, was he? Yet our hair still serves many purposes. Our eyelashes protect our eyes from dust, and eyebrows keep them clear of sweat. Some experts think the hair on our heads even helps stabilize the temperature of the brain. So we probably won't become completely hairless, just a little smoother. And now the bad news. Human beings of the future may have weakened immune systems and become more vulnerable to illnesses. New medical technology and antibiotics can improve our health, but there's the risk that they could make our immune system lazier and unprepared for fighting infections over time. Many generations down the line, it's possible that the human body might not be able to withstand even simple diseases without serious medical help. Today, human development isn't determined by biology alone. Technology also plays a role. Maybe one day, people will stop waiting for evolution to give them what they want and begin to change themselves using advanced tech. Doctors already use artificial devices to help people with health problems. So who's to say that machinery and computers won't be used in the far future to completely change our physical abilities? Our descendants might get different kinds of brain implants. Or it could be that people will be equipped with artificial eyes with camera functions. But in this scenario, we could also end up being less knowledgeable. Why learn a foreign language or remember historical dates when all the world's information has been downloaded right into your brain? If human beings eventually become a multi-planet species and colonize Mars, our bodies could begin to adapt to life beyond Earth in interesting ways. The contrast between the environment on Earth and the red planet is so huge that evolution may actually speed up. In this case, humans could adapt to the new physical conditions in as little as 6,000 years, or just a few hundred generations. In the low-gravity environment of outer space or alien worlds, the structure of our muscles could change. We won't need some of them, while others will develop more quickly. The amount of body fat we have may increase in a cold climate. Low temperatures may also make us grow thick, long hair again. Our skin may become more pigmented and therefore better protected from harmful UV radiation. And our eyelids might get thicker to protect our eyes from all the cosmic rays outside the Earth's atmosphere. When we say extinction, we usually think of dinosaurs that went to lunch with a humongous asteroid and were wiped out from the face of the Earth. We don't think of ourselves possibly going away in the near future. But what we forget is that there have been 5 mass extinctions that our planet witnessed in the last 500 million years, not just one. And we can be nearing the 6th one, where one of the species to possibly disappear are humans. The first great mass extinction came about 440 million years ago in the Ordovician period. Back then, life was mostly thriving in the oceans and along the coastlines. Biodiversity was great at the time. There were thousands of different species, trilobites, sea scorpions, and all kinds of weird-looking mollusks and even fish. You name it, Ordovician had it. But then, the temperature around the planet started to drop. The overall warm climatic zones became colder and colder, until the oceans got covered with thick sheets of ice. Most of the marine species weren't ready for such abrupt changes. Imagine a trilobite serenely crawling along the bottom of the sea and suddenly bumping into a glacier. Yeah, it's like living your entire life in a beach bungalow, only to find yourself in an igloo one day. The event was dubbed Late Ordovician Glaciation, which led to Late Ordovician mass extinction. Over 60% of all species that lived in that period disappeared. Only ancient fossils were left for paleontologists to discover hundreds of millions of years later. Nobody still knows exactly what caused the temperature drop at the time. The main theory is that the CO2 levels in the atmosphere fell sharply. It led to cooling down the entire surface of Earth. But the reasons for such a collapse are still under debate. However, that wasn't the worst mass extinction event in the history of our planet. Despite more than half of all living creatures being wiped out, biodiversity on Earth restored itself in the following 5 million years. Life went on until another catastrophe struck. Within the span of 20 to 25 million years, from about 375 to 350 million years ago, several extinction events occurred. They were like pulses that damaged a lot of marine species. Arthropods, like scorpions and mites, lots of various fish, including sharks, all were in decline. Overall, more than 75% of all living beings disappeared back then, who were mainly in the oceans. The reasons for such events are even more unclear than those before the late Ordovician mass extinction. Most scientists now believe those waves were caused by changes in the sea level and a lack of oxygen in the oceans. A lot of plants quickly moved to land and adapted to living outside of water. And since they were the main source of oxygen in the ocean, all those fish and sea scorpions were in for a very unpleasant surprise. The booming growth of plants on land also removed much of the CO2 in the atmosphere and enriched it with oxygen instead. This led to an abrupt temperature fall again. And although no new ice age followed, many land animals couldn't adapt to the new conditions. The bitter irony was that the major part of them had just recently crawled out on land from the ocean, looking for a better environment. Ah, well. This was only the first wave, though. The reasons for the second one, that came about several million years later, are still unknown. Scientists think there could have been mass volcanic eruptions, or even meteor strikes, but those are just hypotheses. Then another 100 million years passed without much trouble. Species rose and fell, evolved and disappeared, but the cycle of life continued, until about 250 million years ago, when the third mass extinction event occurred. It happened in the Permian period, the last period of the Paleozoic era, and it was so catastrophic that it had all the chances of becoming the last mass extinction on our planet. Scientists are still unsure what caused so many species to be eliminated. But the fact is that around 96% of all living creatures in the world were gone. One theory suggests that volcanoes started being overly active. They threw millions of tons of methane and basalt into the atmosphere. Asteroid strikes might have added to the damage too. The sky was literally covered in dark clouds of ash. The proto-mammals and reptiles tried to hide from the black and gray mist, but it was everywhere. It was like hiding from the air itself. Another culprit could have been microbes that loved their methane-rich environments. They could have quickly spread in the oceans and literally choked the rest of the marine life forms there. But whatever the reason, the Permian mass extinction event was the most massive and destructive of all the Great Five. All life on our planet could have ended right then and there. But those 4% that persisted eventually spread across the Earth and started a new era. Yay! This time, they lived a peaceful life for only 50 million years. And then, whammo, the fourth great mass extinction hit. It was different though, slowly creeping across the planet over the last 18 million years of the Triassic period. The extinction occurred in numerous short pulses, wiping out several species at a time. A slight climate change here, an abrupt temperature fall there, and very upset animals and fish all around. The main reason for that was again the volcanic activity at the time. Fiery mountains started spewing out ash and gas once more, lowering the oxygen levels and suffocating life. Well, that was harsh. The gases and other substances thrown out of the volcanoes' mouths changed the Earth's climate again. Sea levels rose because of that, and some researchers believe even the pH levels were altered. That means the marine life that used to be swimming peacefully in more alkaline waters suddenly found itself trying to survive in acid. But apart from causing bursts of extinction, these changes also ushered in the era of dinosaurs. It didn't begin immediately, of course. Some species evolved and slowly grew into the mighty animals we've heard so much about. Their extinction was the last of the Great Five, and certainly the most well-known. About 65 million years ago, when dinos were still ruling both land and ocean, an enormous asteroid came from outer space and fell right on Earth. The impact was so powerful, it left a huge crater in the Yucatan Peninsula, and the explosion sent billions of tons of debris into the air. The dinosaurs that lived far away from the impact zone raised their heads and saw black and churning clouds blocking the sun. It remained for years, drastically dropping the temperatures. In addition to the cold that followed, the asteroid hit a carbonate rock that had a lot of flammable material in it. The impact led to an explosion. The chemicals mixed in the air and produced sulfuric acid, and that acid fell down in the form of rains, altering the pH of the oceans. Aquatic creatures that were again used to more alkaline waters went, "Oh, come on!" That didn't help, though. The changes were abrupt and severe. About 75% of all animals and plants went extinct in a matter of years, unable to survive the new, harsh conditions on the planet. But some persisted. Many of them were reptiles, like crocodiles and turtles, which managed to survive even up to this day, looking almost the same as they did back in the dinosaurs' days. Others were mammals, which had lived in the shadow of the mighty dinos and hid from them in dark corners. But now that the giant animals were gone, they began to flourish, bringing in the Cenozoic era, the one that lasts to this day. And today, we might be witnessing the sixth great mass extinction. According to scientists, with the evolution of humans, a lot of different plants and animals have gone from the face of our planet, never to return. The good thing is, mass extinctions have always happened over a span of several million years, so we might still have time to recognize it, prepare, and counteract. What do you think? Shall we?
If you've ever hit your toe on a corner and felt that sharp pain, you know what I mean by why we have such delicate feet. Our feet are super sensitive. They're covered with this special hairless skin full of nerve endings. That's why it hurts so bad when we get a foot injury. Yet they aren't as delicate as we think. It's incredible how our feet are put together. They consist of 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments. These are working together like a machine to let us move around. When we run, our feet work like springs. They must handle up to 7 times our body weight every time they hit the ground. Thanks to the clever arrangement of ligaments, tendons, and muscles, our feet store and return much of that force to the ground. By the way, they can also give us hints about our overall health. And every pair of feet is unique. No two pairs are exactly the same. They come in different sizes, shapes, flexibility, strength, and walking patterns. It's like our feet have their own personalities. But how have our feet come to this point? Researchers have been trying to figure out when and how early humans started walking upright. Well, they've been looking at feet, toes to be exact. Bipedalism, which means walking on two legs, was a major step in human evolution. It influenced a bunch of other changes in our lineage, like how we behave socially and develop our material culture. So, these scientists have been digging into the details of foot evolution to piece together the story of our species. The team has been checking out these special joints called metatarsophalangeal joints, which are placed between the long bones of the foot and the toe bones. In 2015, they found that, unlike in other primates, this type of joint in humans faces upwards, allowing us to extend it, which is perfect for walking on two legs. But apes and other primates have downward-facing joints, giving their feet a hand-like grasp. In their latest study, the researchers looked at fossils of primates and hominins, a human group, to see when this upward-facing joint first appeared. It turned out it had shown up about 4.4 million years ago in the lateral toes closest to the outside edge of the foot. Yet the big toe kept its downward-facing joint until much later, about 2.2 million years ago. So, it seems like early feet might have still kept some grasping ability while people were adapting to walking on two legs. The fully bipedal adapted big toe evolved relatively recently. But weirdly, our feet didn't leave much of a trace in the fossil record until recently. It's frustrating because understanding how our feet evolved is crucial to unraveling the story of human evolution, especially when it comes to walking on two legs. Our modern human foot evolved separately to suit different needs. The chimpanzee foot is more flexible, suitable for climbing trees, while the human foot is stiffer, perfect for bipedal walking. Speaking of feet, we might as well talk about the benefits of walking barefoot. It can actually bring us closer to our natural walking pattern, or our gait. That's a good thing, because it allows our body to move the way it's meant to. Shoes can make you feel like you are walking on clouds, but they can sometimes hinder certain muscle groups from doing their job and strengthening our bodies. But when you go barefoot, for starters, you have better control over how your foot lands on the ground. This helps with balance, body awareness, and even pain relief. Plus, it can improve your foot mechanics, which can positively affect your hips, knees, and core. It keeps your foot and ankle joints flexible and strong, thanks to the proper range of motion and muscle stability. And let's not forget about those uncomfortable shoes that don't fit right. Walking barefoot can relieve issues like bunions or hammer toes caused by improper footwear. Have I mentioned stronger leg muscles? Yep. Going barefoot can give your legs a nice workout, which is excellent for supporting your lower back. So, kick off those shoes and let your feet breathe the next time you find yourself on soft grass or sandy shores. Your body will thank you for it. Not just our feet have evolved over time. Our ancestors had bigger brains too. It means our brains have shrunk. Researchers looked at cranial fossils and discovered that our brains started downsizing about 3,000 years ago. Agriculture took the stage around 10,000 to 5,000 years ago, and civilizations sprouted like mushrooms after a rainstorm. There were sprawling cities, architectural wonders, and even some fancy writing thrown into the mix. The connection between brain size and IQ isn't as straightforward as it seems. Many critters rock brains that make ours look dumb. A massive study with thousands of brain scans and IQ tests revealed that brain size and IQ are like two friends at a party. Sometimes they dance together, and sometimes they go solo, with no strict correlation. It turns out some ant societies are like a mirror to our own, complete with their own version of farming and teamwork. And ants with bigger societies have bigger brains, except when they get into the whole farming gig. But smaller brains might be a cooler choice when teamwork gets super complex. Maybe the invention of writing around 2,000 years ago also played its role. It's like the ultimate external brain. You write stuff down and boom, you have ideas at your fingertips. It's like your brain is outsourcing its memory power. Here is a recent thing you might want to consider, especially if you are a gamer. Some streamers have made an unexpected discovery after spending countless hours wearing headphones. There's a headphone-shaped groove on top of their heads. Let's bring in science before we all start imagining our skulls reshaping like Play-Doh. It's highly unlikely that headphones are engaged in skull remodeling. According to experts, giving a human skull a makeover takes 297 pounds of pressure. So, what's really happening here? The headset is just giving a friendly nudge to our softer bits and pieces, causing a temporary dent that can be smoothed away. Another thing is about your phone holding style. Do you use your pinky to prop up the weight of your device, forming a sort of locked-in position? Ever wondered if this way of gripping might be causing some issues to your hand's well-being? Now, as smartphones keep getting bigger and better, a funny thing is happening. More and more people start noticing this smartphone pinky issue. You might have noticed a tiny groove forming on your pinky from being a loyal phone holder. Let's set the record straight once and for all. Holding your phone this way for long periods can actually bring some trouble. A common issue here is a trigger finger. Basically, bending your small finger to cradle the phone can cause it to get stuck in a flexed position, especially if you've got a trigger finger lurking beneath the surface. It's like a tiny finger traffic jam. Treatment often involves injections or minor procedures to release the tendon tangles. Your wrist might also decide to join the hand-hurting parade. This one causes numbness and tingling in your thumb and other digits. Plus, when your elbow is flexed, like when you're holding your phone to your ear, it can put pressure on the ulnar nerve, leading again to numbness and tingling in your ring and little fingers. Interestingly, apart from a tiny muscle called the erectus, our fingers don't have muscles. So how in the world do we wiggle them? The muscles in our forearms are like puppeteers pulling the strings behind the scenes. These muscle maestros initiate finger movements, and here's where the real magic happens. Those movements are like secret messages zipping down to our fingers through tendons. Think of tendons as those trusty messengers delivering commands straight to our fingertips. How's that for finger wizardry?
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly.
5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, but if they fell, they could never get back up. The smaller dinosaurs like Triceratops had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash. 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1,000,000 years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much later came the iPhone. With more than 8 billion people in the world today, it's hard to imagine there was a time when there were so few human beings that they almost went extinct. It happened about 900,000 years ago when our ancient ancestors faced a crisis. Recent studies tell us there were only about 1,280 of them left, which is an incredibly small number. It's like just one village or a very small town left alone on the whole planet. The human race got into a population bottleneck where almost 98% of people disappeared, and things were tough for them for more than 100,000 years. We don't completely understand why this happened, but it was likely the result of tremendous changes in Earth's climate. It was a time when periods of cold weather lasted longer, the sea was colder, and there were more glaciers. Monsoons were immensely powerful, and yet there was less rain. These changes had an impact on wildlife species in Africa and Eurasia, and many plants and animals that were food sources for people disappeared. But at some point, our ancestors showed their strength and managed to bounce back despite tough times. The numbers started to go up again because people learned how to handle fire better. Plus, temperatures got warmer too. But what would the world look like if nature had defeated us and it all had really stopped for humanity back then? Let's take a trip to some parallel dimension where it really happened. In that universe, there wouldn't be empires, pyramids, and impressive achievements that some old civilizations left us. No neighborhoods, cities, your favorite park, or that bench where you like to sit and drink your coffee. No coffee. Ouch, that hurts. No pools, adventure parks, and no rush at the beaches. No creature would be able to go to another continent separated by the ocean. There would be no ships or planes that could carry it. Animals would have to wait for tectonic plates to move again to visit new territories. Wow, you've just realized how incredibly silent the world is. All because nature almost never produces as much noise as humans do. Our buildings are noisy, together with cars, motorcycles, and all other vehicles. If you live somewhere by the airport, you know how much noises planes can make too. And here, no one's phone's ringing. You don't hear music coming from bars or gyms. Wow, look how incredibly blue the sky is. You've never seen a sky like that in your world. The rain and wind scrub the surface of our planet clean, although there's not much work to be done since there's no dust and smog humans produce. I mean, there is dust, but a different kind, one that nature creates. We don't really notice it since we have so many heaters and air conditioning systems that blow air and all that dust around. The only drinking water you see is in lakes and rivers, and lots of different animals get together in these areas. It takes a while to get used to it. Wherever you go, there are wild animals passing by. There are no dogs, cats, or other pets you're used to. There's no electricity either. In case you've brought your phone, take pictures as fast as possible because you won't be able to charge your gadget when it runs out of battery. There's no internet though, so you'll be the only one who will see the photos. It's so weird to see grass so tall and wild. No one mows it, so it's hard to walk, especially considering there are no roads. And you don't have a scythe or any other tool that could help you clear your way, because human civilization hasn't reached that level of progress. Wow, there are plants you've never seen before. Every time a tree drops a seed, something new might grow. And there are no humans to select which plants they like and which they don't. You suddenly feel nostalgic, thinking of carrots, broccoli, potatoes, and all other vegetables people once started growing on their farms. You can hear tons of bugs buzzing around. We usually do everything to get rid of them, and now, without humans, you get to see how annoying they really are. Hey, the sun is going down. Without electric lights, all creatures just follow the rhythm of nature. So, if you're up for a late-night walk, wait for the moon and stars to lighten your path. But be aware of night predators. You may face creatures that didn't survive in the world where humans rule. Fire. Luckily, there's a river nearby, so you jump into the water to get to the other side. Fires happen more frequently in the world without humans. For instance, lightning can strike a tree or set a brush on fire. No one is there to put the flames out, so fires just keep spreading until at some point they burn themselves out. It's hard to see the world like this, but it's even harder to accept that Earth is fine without us. Just like it's doing well without dinosaurs, megalodons, woolly mammoths, dodos, and other ancient creatures that went extinct. Back to the research. Some scientists don't think our ancient ancestors were really that close to extinction. To get these results, researchers used FitCool, a special tool that helps study changes in ancient human populations by looking at the genetic information of modern people. They examined DNA from over 3,000 individuals in Africa and other places for this study. Some believe that the actual population numbers might have been bigger. The method used focuses on a small group of breeding individuals and may not exactly represent the whole population. There may be many archaeological sites in Eurasia and Africa that date back to the time when this population decline might have happened, so it may have affected just some groups of people in certain areas. Either way, not only wasn't it the end, but it was a new beginning. Two ancestral chromosomes combined to create a structure known as chromosome 2 in modern humans. This might have been the start of a new species, because there was a split between our ancestors and other ancient humans, such as Neanderthals and Denisovans, our ancient cousins. Some evidence tells us this idea is plausible because our common ancestor lived about 500,000 to 700,000 years ago. Well, humans did survive all those devastating moments in history, but scientists believe that the extinction of our species is a matter of when, not if. Our fields will overgrow, cities will end up in ruins, and bridges will fail. Nature quickly reclaims the landscape where humans don't go. Check out how these roots and trees have taken over the temple in Cambodia. Roman ruins still defy time for over 1,500 years now. Some of the buildings and things we create in the modern world will do it too. Nature will break everything down at some point, and if humans were to go extinct, who would replace us? It took 200 million years for our kind to evolve from the first mammals. Who can repeat this entire process again? The last common ancestor of chimps and humans lived 8 million years ago. Knowing this, it seems possible that if Homo sapiens went extinct, a new species capable of using technologies would evolve from chimps. But hold on. There's something called the Fermi paradox. Even though there are hundreds of millions of rocky planets that could host life in our galaxy, we don't see any evidence of its existence. Our galaxy is 13.5 billion years old, so you can't say life hasn't had time to develop. One possible explanation is that certain crucial steps in the evolution of intelligent life are so rare they hardly ever happen. So, Earth would get along fine without us. The only ones who would care are us. And right now, we need to care a lot. Can you imagine that all modern humans came from about 1,000 people? Around 800,000 to 900,000 years ago, almost all of our ancestors disappeared, leaving about 1% of the population behind. So, what the heck happened? The Earth often goes through glacial cycles, things that we call ice ages. Back in the past, they were pretty mild and happened regularly, about every 41,000 years. The ice ages happened because of the Earth's axis. Our planet is slightly tilted at an angle, which is why its axis isn't straight up. Over thousands of years, this tilt has changed a bit. This teeny tiny shift completely changes how much sunlight we receive, especially at the poles, and leads to incredibly strong cold or warm periods. About 2.6 million years ago, when early humans were settling in on Earth, the Pleistocene epoch started. That's the era we traditionally call the Ice Age, the one from the movies. Large ice sheets completely covered parts of North America, Europe, and Asia. It wasn't constant ice everywhere all the time. These glacial cycles came and went, and sometimes ice sheets melted for a while. But overall, things were still much snowier and colder compared to now. We can still see the evidence of this from back in the day. Those glaciers carved out valleys and left behind some awesome things like moraines and fjords. And since sea levels were super low, a huge part of the world was land. This allowed people and animals to travel between continents and spread everywhere. It was the time of the megafauna. You all know about it from the movies. Woolly mammoths, saber-toothed cats, giant ground sloths, and mastodons. Our ancestors had some fun times hunting all those giants. Now, humans didn't come from one lineage. It wasn't like monkeys slowly turned into humans. We also consisted of many species: Homo erectus, Neanderthals, and so on. But only one species, Homo sapiens, survived and turned into modern humans. Harsh conditions forced them to get smarter. They learned how to make tools, clothing, and shelters to survive. They became hunter-gatherers and invented fire, which turned out to be super useful during the Ice Age, you think? But they had no idea what horrible change was coming. Something disastrous happened about 800,000 to 900,000 years ago. Humans faced a drastic population crash. Only 1,280 people survived, give or take. Some 99% of early humans were wiped out, and this tiny 1% was lucky enough to become our ancestors. This almost extinction, unsurprisingly, was the climate's fault. It was the Middle Pleistocene transition. The Earth's orbit around the Sun changed its shape a bit. Carbon levels dropped. A lot of stuff was happening, and the Earth's climate was going wild, becoming incredibly cold and dry. The seas suddenly got chillier, and Africa and Eurasia experienced horrible droughts. Looking for food was almost impossible. Scientists learned this by taking the DNA of about 300,000 people from all around the world. They used a new method to help them map the history of human evolution over 1 million years and learn more about it. No wonder we can barely find any fossils from that time. There was almost no one around. What's interesting is that before that happened, most apes had 24 pairs of chromosomes. But because the population became so small, 2 sets got fused together, and we ended up with 23 pairs. This was the final straw that separated us from other apes. Chimpanzees, gorillas, and orangutans all have 24 pairs, but our fused one became known as the human chromosome. Like a ripple effect, this little thing influenced our brain side, helped us start walking on our toes, and even form language. It took humans about 100,000 years to recover from this catastrophe. Only after all that time, they started spreading around again. Isn't that insane how we managed to go from 1,000 to 8 billion people? In any case, the Ice Age finally ended about 11,700 years ago. The warm period, called the Holocene, began. As things got warmer, human civilizations finally began to develop. 5,000 years ago, it was ancient Egypt, then the Indus Valley Civilization, ancient China, and others. And while we've been thriving for a while, there's one catch. The Middle Pleistocene transition changed the length and intensity of glacial cycles. Before the transition, sure, there was the Ice Age, but the cold was milder, and the glacial cycles were shorter. Things got covered in ice sheets about every 41,000 years. But after the transition, the glacial periods became longer and more severe. These cycles started following a new pattern. Although they happened every 100,000 years, they were super intense. Ice sheets grew large, even extending to the south. So from now on, ice ages that will continue to happen in the future will be a bit different. The next one should be at least 50,000 years from now, maybe longer. It's good for us because it'll occur later, but at the same time, the consequences will be stronger. What our ancestors went through is called a population bottleneck. That's what we call a sudden and huge reduction in the size of a population. Usually it happens because of things like earthquakes, floods or droughts, fires, and even human actions. Just a few people survive, and only they can pass their genes to future generations. And we've got plenty of such bottlenecks in history. Our modern species, Homo sapiens, originally lived in Africa. Around 60 to 80,000 years ago, a small group of them left Africa and spread across the world. It wasn't on a whim, though. They had to move somewhere because of the droughts and huge climate problems in Africa at that time. They had to go look for food and find new places to live. They traveled through the Middle East, moving into Europe and Asia, and eventually reaching Australasia and the Americas. They quickly settled across different continents and started mixing with local human-like species, like Denisovans and Neanderthals. But there was a problem. Originally, the African species were super genetically diverse, but since only a small part of them decided to move out, they carried just a bunch of these diverse genes with them. Unfortunately, this caused a bottleneck for everyone. Human-like species from other parts of the world became less genetically diverse. Since they had a smaller gene pool, they became more vulnerable to all the harmful stuff. The African population also had a drop in genetic diversity. But at least humans managed to survive. Although eventually, non-African populations really dropped, and there were no Neanderthals or Denisovans left, only us, Homo sapiens. That's why we can say that all modern humans came from Africa. Early humans sure had it rough. About 74,000 years ago, they went through yet another disaster, the Topa catastrophe. But keep in mind that all these things are just a hypothesis. It's not certain whether it actually happened. Now basically, scientists think that there might have been a supervolcanic eruption at Lake Toba in Sumatra, Indonesia. This volcano going crazy was an absolute catastrophe for Earth's climate and humans. The eruption was one of the most powerful volcanic events in the last 2 million years. It spewed out from 670 to 1,500 cubic miles of lava and volcanic stuff. Just so you know, there are about 3,100 cubic miles of water in our planet's entire atmosphere, and this eruption had almost half as much lava. This horrendous disaster led to the formation of Lake Toba, a massive caldera lake in Sumatra. It also spewed out tons of ash and sulfur dioxide into the atmosphere. This caused the so-called volcanic winter, which means that while it's not actually winter, the temperatures drop and the planet is freezing because all these ash clouds are blocking the sunlight from reaching the Earth. This event affected climate patterns for years to decades. This also most likely sped up the arrival of the next glacial cycle. Luckily, humans are crazy good at surviving. The global human population was reduced to a few thousand people yet again, and they still managed to overcome this.